We were up to about number 2 in Brazil, and we got Rig of the Year globally for INSCO that year. So really that turnaround story was almost compelling enough for me to maintain a role as oil went to $10, but unfortunately oil went to $10.
All right, welcome to Local Energy. My name is Peter Brecht. I'm here with my co-host Wade Spear, and our guest today is Joe Dillon at Atacon Energy Solutions. Joe, thank you so much for taking the time out of your day to meet with us, and I'm so excited to talk with you.
Hey, Peter, Wade, thank you. I'm excited to talk, happy to make the time, and looking forward to talking some energy today. It'd be good.
Yeah, so you kind of snuck up on me on Twitter. We have someone we follow mutually, and there was some conversation around the grid and stability, and I was like, "Who's this Joe guy? Like, your profile photo is not you, or it's some version of you that a caricature of some sort." But anyways, there were some comments there, and I kind of looked on your profile, and then the one thing that stood out to me is your actual your Twitter bio is, so you're obsessed with the grid, right? You're just, this is like all you do, all you live and breathe. So I connected with you. You were gracious enough to come on as a guest, but your background it starts offshore, right? Offshore oil and gas is where you began. So I kind of wanted to touch on that a little bit and, maybe share about your past and where you've been.
Yeah, Peter, happy to. And maybe it'll give a little color on kind of how I ended up where I am today. But so coming out of college, I was working in Houston doing some land development work and some like environmental permitting work for industrials, and had the opportunity to go move overseas in my mid-20s to work for initially the American Bureau of Shipping, which for those not familiar with the offshore world is kind of, I always referenced it like they're kind of like the UL Labs or the Standard & Poor's of things that float, where you're the regulatory agency that's certifying the seaworthiness and operational ability of offshore boats, platforms, etc. And so I started with them on the oil and gas side in Singapore, which at the time was the largest offshore rig building nexus in the world. I think there was like 22 or 23 different offshore rigs under construction at the time. This was back in the mid 20-teens when the offshore was very hot, similar to kind of what I think we're at the beginning of now, that I'm sure we'll get into. But so I was with them for about 2 or 3 years. And I think something that frustrated me a little bit is you were kind of the guy that goes around and points out what's wrong, but you weren't able to like fix anything because that wasn't really the role. You could kind of be in that regulator hat. And so after about 3 years or so, I switched over and spent the next probably 8 years overseas working for Transocean, INSCO, which is what is now Valaris, building. I was kind of one of their project manager, senior project manager. So they just sent me whatever was most broken and said, "Hey, this project's way behind. This project's broken. This person messed it up. Come fix it." And that kind of culminated in Brazil, where I was given an old 1980s semi-submersible drilling rig that was ranked 52 out of 54 rigs in Brazil by Corollary. It wasn't so great globally. I got that in January, and by the end of the year, we took it through a shipyard, and then we got back to work, and we were up to about number 2 in Brazil, and we got Rig of the Year globally for INSCO that year. So really that turnaround story was almost compelling enough for me to maintain a role as oil went to $10, but unfortunately oil went to $10. So I rotated back to the States and kind of finished up my MBA with Carolina and started working with Honeywell running their smart grid solutions business, which is their global energy efficiency and demand response business, which is, there's interesting corollaries there to tie back to like how you build oil rigs, where you have kind of this system where you're trying to balance all of these different loads against the generation from your power plant inside the rig, and you're kind of islanded, where if you mess up, you lose your power, and that's bad. And so ran that business for several years and realized it was almost too hard to change from within a big corporate environment. So about 5 years ago, I founded Atacon Energy as an industrial development firm that's really focused on that seam where load meets generation. So flexible load, co-located load at generation, or, placing new greenfield thermal generation at points where the grid needs it.
Hey guys, thanks for listening to this week's episode of Local Energy. Please remember to like and subscribe to us here on YouTube or Spotify, and check us out at localenergy.com. All right, now back to the show.
one more quick point is like looking at the amount of intermittent renewables we've placed on the grid over the last 15 years, which isn't political, that's just facts. The
Right.
penetration rate, we're kind of getting into that low double digit penetration rate of renewables across some of our larger grids. And that has created instability potential within the grid as far as you have reduced spinning mass during parts of the day where the wind is blowing and the sun is shining, and you have, increasing transmission challenges since we used to pretty tightly co-locate generation with population or with users.
Mhm.
Now we've got intermittent renewables kind of geographically, spatially separated, as well as, less unknown time production. And so
Yeah.
it's kind of gone from being a command and control system on how the grid is operated to really moving toward more of a market-based structure. And we've seen that over the last 20 or 30 years, but we're starting to see just tons of new volatility entering the market from there. And we think that you're going to need somewhere between 600 gigawatts and a terawatt of new generations slash flexible load just to balance the intermittent renewables that have been added to the grid. So that I would say excludes what we're going to need for all of the new large buyers, such as the AI,
Mhm.
hyperscale. The Bitcoin is pretty flexible, but you also have a lot of EV adoption and just general. We've essentially gone from a grid for 40 years where we were growing at 2 basis points, 0.02%, to a grid that's now growing at 5 to 7% a year. And so we're starting to see some of those dislocations. And so that's what we're pretty locked in on that. I think, I graduated right around when from Tulane in New Orleans, right around when Hurricane Katrina hit, and having lived overseas quite a bit in my life, I've seen kind of what happens when the power goes out, and we
Mhm.
really don't want to be there as a nation. And so that's kind of where we try and stay in our lane and just what can we do to help increase grid reliability and improve resiliency by leveraging some of these new loads that are coming on.
My wife, as I mentioned, she surfs, and so we went to Puerto Rico for a 2 week vacation. And
Oh, awesome.
vacation is heavily in quotes because the power was out for the first 3 days we were there. It was 90 degrees, humidity off the charts, so no power. Then eventually you have no water because you have no power. And I mean, it's Puerto Rico, so you kind of are okay with it because the surf is good and the rum is good and all that fun stuff. But the reality is, I mean, if we have the fragility of our grid, I mean, the town I live in would be up in arms within, a day or two of power being out like that. So I don't know. I just, hopefully you're successful in what you're doing.
I was just wondering, so when you refer to flexible load, like what are you talking about? I mean, is this like being able, I mean, are you kind of talking about like storage and being able to bring it online whenever you need it, or kind of what are you referring to there with flexible load?
So our most recent portfolio project we built out is up in North Dakota near the
Okay.
Bismarck area, and that is co-located at a plant called Coal Creek Station, and it's run by Rainbow Energy. They have been trading physical power for 30 years. They also have, a pretty big energy business broadly. They're private, so they're a little bit more under the radar, but
Right.
we put down a data center there that's about a 220 megawatts of load, and it sits directly co-located with the plant. And so you
Okay.
could throw a baseball and hit the generation facility. That plant has some interesting characteristics where it's a 1.2 gigawatt plant. It's one of MISO's 5 black start generators. So if you have a full blackout in MISO, this is one of the ones you use to kind of reboot the grid. Unique decision was made in the 60s where they decided to build a high voltage DC line directly to downtown Minneapolis and place the generation facility on top of approximately 50,000 acres of the cleanest burning lignite coal in the United States. And so they've continued to lean into that. It's the conservation efforts they do are amazing, and they also have all of their, clean coal and scrubbing everything. And it's the largest carbon capture project in the world, I think, that's kind of continuing to kind of inch along. But from a
Hmm.
performance perspective, that effectively lets us take that power plant and make it look like a battery. So we can kind of step through some of the different benefits to it. On one hand, the plant is getting a firm consumer of power at a firm price. And that is one
Okay.
area, kind of those northern plain states and northern Midwest, they economics for a lot of thermal generation has been really impaired because of the wind that has come up and because of, to some extent, the solar. When that happens, now you're running into plants that were built to be baseload plants like steamers,
Hmm.
big turbines. They take a long time to heat up and cool down. And when you cycle them, stuff just breaks. Like, I mean, there's some of the most well-engineered generating facilities in the world, but they're designed to run all the time. And so this helps preserve that baseload demand for those plants, while simultaneously we've interlocked the power supply with the plant and with the grid. So if there is a grid stress event or some kind of power pricing event that requires we need to dispatch more onto the grid to help lower prices for consumers, we can take that 220 megawatts down to about 7 in about 90 seconds, which is, you could go faster, but the DC line can only change 100 megawatts a minute. So it's probably the largest fast responding large load in the country, we think, the fastest large flexible load in the country. What that results in is it allows you to capture economics from when the grid is very volatile and prices are very high. And it also allows the plant to operate at a base level. I mean, it's the largest employer in North Dakota. There's a lot of second order economic effects that are pretty important for these plants, as they're centers of the communities they're in. So that works great. That's all kind of written into the power agreements for the customers. Those customers are all institutional grade, public style Bitcoin mining firms, but they've all, this is not someone with some machines in the back of a truck. Like, these are, public companies that are global in reach and have, kind of that credit worthiness that makes a lot of sense for the power groups. And so we kind of we've been acting as a coordination layer there. We help de-risk those projects a lot, where that's part of why we used multiple tenant approach, where when you start getting into the sizing of these facilities, you really don't want to have just one customer that may disappear for whatever reason, just idiosyncratic risk. And now you've got kind of a stranded asset there. So we were able to kind of bring that from PPA signing to full loading within about 18 months with 2 North Dakota winners. So apologies we haven't met earlier, Peter. It was a pretty busy couple of years.
Yeah, no kidding. No kidding.
So from there, that's really helped develop our thesis more deeply. And we've got some active conversations with incremental power plants on how we can co-locate with them, as well as a new energy campus where we're actually acquiring the generation facility out in Texas to kind of bring that to market as a load balancing, hyperscale quality campus.
Gotcha. I think one thing, and you mentioned, North Dakota, I think, we've all read those articles, or some of us have, about, the people in these places like North Dakota, Wyoming, that are complaining, whether it's noise or power going up, from these data centers and from the Bitcoin mining. I mean, I'm sure just to start those companies, you have to do a lot of research around the demographics and the impact on the environment, all those, right? But I guess, what's your thought process, or how would you think through how those articles are portrayed?
This is a really good question. And this is near and dear to my heart, Peter, because I think there is a lot of education yet to have or to put out there around this topic. I think the noise issue has been is kind of fading away a little bit. Most of the new data centers, especially the hyperscale, like Magnificent Seven, Oracle, Amazon guys, they're all using closed loop systems at this point. I think the last major data center build I saw, Google did what was then a relatively large data center in 2017 that still used evaporative cooling. Basically, every design we're seeing come out of the market now is all this closed loop cooling. So you do get a lot of kind of smoke around all of this water usage, all of this resource usage that I don't know that is substantiated by kind of what equipment is actually being put in the ground. Right now, we've got a couple consulting firms engaged to actually run the analysis on our curtailment activities, because it's demonstrably cost saving to the end consumer when these kinds of loads are placed at the generation facility than when they are maybe front of the meter. I think there is often a misunderstanding, and I think there's been some interesting charts coming out that show districts and service territories that have more large load in them generally have lower electricity prices for residents. Part of that reason is a lot of the rise in retail rates over the last 3 or 4 years has been due to a bunch of wire and lines build out. Like, think about, we spent 2 decades building suburbs everywhere in the country, right? And that is everybody has to have a line running directly to their house, and a whole suburb may use 5 to 10 megawatts of power, right? Well, if you put in a new manufacturing facility that uses 5 to 10 megawatts of power, you are running one line there and you are putting 1 meter in, and that person is paying for a lot of power to keep that line full. In residential areas, lines are pretty empty because they're sized for Thanksgiving dinner and Christmas Eve and the 4th of July. You know, they're sized for the peak usage at home, and you don't really have so a lot of times, a lot of those power bill increases people are seeing, they're paying for underutilized lines. And so at a grid level, the way you can fix that and keep those lines full so that those line costs is distributed to more megawatts is to have things like large flexible load or large consumers that also have generation, so they can kind of present a very steady consumption picture to the grid.
Well, not to mention that you also have RTOs, which I'm sure play a factor in how all this works out as well. Like, I mean, I'm in an RTO in California. And I can tell you right now, this is something that I think about a lot is, you know, we'll have our utility company will come out and have a meeting about things, and you'll have all these people show up, and they get upset. Most of them, they're older folks, and they're on a fixed income, retired. They're just there to listen to what I've been to one or two of them because I'm just curious, like how these are run. And a lot of it just feels like a sales pitch, because at the end of the day, I know they're not going to do anything. You know, the 20 or 30 people in that room in that little tiny, suburban corner of California, it's not like it's going to change our utility company's mind. So I think a lot of that too, like the RTOs have to play a pretty big role in the conversations you're having too.
Yeah, I think that's primarily one of our major engagement points, Peter, and we've seen that grow is we are, especially as that North Dakota site has really kind of been up and running for closing in on a year at full capacity. The, great example there, some of the leadership in MISO, which is kind of the RTO that's the Mississippi Valley, basically. We've had active conversations with them on how to design incentive structures so they get more of that into their grid. I think we talked recently with some of the heads of SPP, which is kind of the RTO of all the big square states in the middle. I'm from one of those big square states, so I can say it. Yeah. It's fine.
Yeah.
But they're pretty actively looking at like, how do we get people to be able to connect faster? How are we able to improve, some of this new industrial load that wants to come in, because they have a problem of they have a bunch of generation and a bunch of wind and a bunch of solar, but all their load is very concentrated in Kansas City or Oklahoma City or Stillwater, and there's a lot of empty space that is, you got to build lines for. And then in ERCOT, you have probably a hyper aggressive approach. Historically, they've been able to be more independent since they operate a independent grid from FERC regulation. And that is a dynamic environment. I'm sure anything I said about that would be out of date by the time the podcast hits the air in a week.
Yeah.
So, but
yeah.
We're seeing some of them start to wake up and move that way a little bit. There's a lot of inertia, I think, just because historically these organizations, large utilities, RTOs, they were built for stability, and stability historically meant keeping things the way they were because we had a pretty well-designed system. And you're trying to make those organizations turn into, okay, now we're going to grow 100 times faster. It's not that people aren't talented enough or they can't do it. It's really just a cultural change that takes some time and education. And so we invest a lot of effort in that to try and, because it's going to take a nationwide effort really to kind of continue to work towards stabilizing this than, just a couple of guys running around trying to do this helps, but you're going to need to kind of shift the Overton window a bit.
What's one of the biggest misconceptions from, your traditional energy executives? Like, is there something that, not everyone's aligned on that's causing that, or maybe there's a few things, but is there maybe one thing in particular?
So I've seen the willingness to evaluate flexible load like Bitcoin miners and some of these kind of alternative technologies improve dramatically over the last 2 or 3 years. I think that something we see a lot still is there have been a lot of submissions for new load interconnects in the last couple of years, right? Between AI and everything else. Prior to that, what kind of got us into this mess is there was just immense speculative submissions around wind and solar farms where people would just go pile up a bunch of speculative slots. And then when you get into it, it turns out like maybe one of them is real. I think a lot of the large RTOs and utilities are over-indexing that this is the same, because everything we're seeing in the market is the developers and the large hyperscalers that are coming into the market, all of their load submissions are it's not or. Like everything they're putting in, they're planning to execute if they can get approval fast enough. And that just is very hard to comprehend for a lot of these groups, because Texas, I think, is an 80, 90 gigawatt grid, and they're talking about adding 20 to 30 gigawatts of load to it from just large consumers in the next 5 years. Like that's crazy historically speaking, but everything that we're seeing day to day is that's very real. And if there's more that can come, there's more capital that's willing to deploy there. I think
Wow.
I'm firmly on more of this big AI push is probably closer to the middle of the first inning than the middle of the eighth, which I think you've seen some, a lot of the news lately has been like, oh, it's a huge bubble. And I just think it's still very early.
I would agree with you on that. That's kind of my personal belief also. I'm not sure about, NVIDIA giving $1 million, 100 million here, and then it kind of cycling through. That's interesting to me. Not sure how that'll play out, but I think overall, I think we're early.
The way I would like to put it, Peter, is I don't know who is going to allocate capital poorly and go bankrupt. What I do know is that
Yeah.
once those facilities are in the ground, and we've seen this historically with some of the Bitcoin infrastructure, the LLCs or S corps that run the entity may change, but they keep running. So the megawatts
Yeah.
still get sold, the compute still gets processed.
Yeah.
And so you're not going to see this big capex build out and then that infrastructure go dark, kind of like fiber did. I'm
Mhm.
pretty far away from seeing that as happening right now.
As I was getting ready for this interview, Kevin Kelly published an article, and he's this just very great author. He writes something called the Technium. That's his newsletter. But he talked about there's kind of a tension between environmentalists and technology, right? So environmentalists say that tech is not capable of being green, and you have to kind of keep endlessly growing in order to keep the system going. My question to you is, what's your perspective between technology and environmental sustainability? Like, how can those two things come together? Because at the end of the day, I mean, I look at nuclear power. Like, I love nuclear. Like, that's kind of I don't know why we don't do more of it. I don't understand why we don't. I think it's the greenest technology you could come up with. But realistically, I mean, that's a very adversarial comment to make, right? So, I mean, how do we bridge the environmentalist conversation with the need for growth?
This is a good question. Let me break this into a couple parts here, Peter. I think so. First, just a quick aside on the nuke thing. I mean, it's pretty obvious to me that the U.S. Navy has figured out how to build SMRs for the last 30 years. So I'm just continuously puzzled on how we can't figure out how to. And I'm certain that those contractors like money. So I'm just baffled as how deploying additional nuclear in the U.S. has been so difficult. So I'm fully aligned with you there. I think what happens on the technology versus environmental debate a little bit is a lot of, I think, short time frames tend to like warp people out of perspective a little bit. Like if you look back from even the 1800s to now, so call it 200 years, we have rapidly and aggressively decarbonized our energy pool in that, even at the same time while exponentially growing it, right? I think something like 90+% of primary energy use in the early 1800s was wood. And so we went through wood to coal, and then oil came in, and gas, and all of these are progressively been cleaner technologies as we've gone. And I think you saw some of the recent big build out in the environmental, with intermittent renewables the last 10 years feels like almost like they're trying to force it to decarbonize faster, which is an approach you can take. But I worry that you begin to underweight the importance of having reliable access to electricity power, as well as the available to serve your like industrial base as well as your residential base. So there has to be like kind of like a Maslow's needs where like lights and food are going to be above, completely decarbonizing the entire energy stream. And I think you just have to, I think it happens over time. And that technology is what enables the decarbonization to happen. And so, yeah, are there ways to improve it? Yeah, we should build a whole bunch more nukes. I agree. We have a lot less grid stability work to do if we had, spent $2 trillion on nukes, but this is where we are, and now we can move forward from there.
Yeah, I mean, not far from my home, the San Onofre nuclear power plant's getting shut down. Like, I mean, they shut it down, and now it's, now they're deconstructing it. And when I was growing up, a friend of mine, his dad worked for the plant, and he was a nuclear physicist and would go. And I was like, we'd go to their house for dinner, and my parents were cool. My dad would ask what he does for work, and they talk about it. And I was just so fascinated. I mean, this guy would get up in the morning, drive 2 hours to get to the office, and like the dedication, but then like all the cool things that he would tell us about, like what they can do with nuclear. I was always blown away by it, right? And then simultaneously, we have Carbon California that pushed all these dealerships sell more electric cars by 2030, and what they don't realize is how many stakeholders are involved. I mean, there's buyers and sellers, right? People have to want to buy it, then you got to figure out how to charge it. There's just so much going on. I love your point though. It's like it's gonna take everyone to get there, but at some point, right? It stays even anyways. Everyone's gonna keep consuming power at the same rate or more.
Yeah, if you are incentivizing a quote cleaner emissions profile, the
Yeah,
costs of that I don't know are fully appreciated, right? Since it's
right,
not like the economically optimal answer. And there's a balance here, right? Like we're not looking to catch the Erie Canal on fire again. Like
right.
we've made huge strides in the country and globally on
Yeah,
improving pollution. But at the same time, if you either bankrupt or brown out big parts of the country while you're doing it, well, then that's not going to work either. So we have to kind of
yeah.
figure out how to combine these into a cohesive energy plan, which is something I feel like we've lacked a little as a nation in the last couple days, forever.
Yeah, absolutely. So you've touched on Bitcoin briefly, and I didn't want the show to be all about Bitcoin, even
Sure.
though I could talk about it because I think it's a incredible I don't know if you can call it asset or invention, but you work with Lightning Ventures, is that right?
I have, yeah. I've been a little
Okay.
bit quieter with them the last couple of years, but I know that group
Okay.
over there and they're really good.
Yeah, I mean, I just, my familiarity with them, I looked them up real quick as I was going through. But I mean, they're talking to Willie Woo and Adam Beck and Preston Pish, and, he's got a great podcast. And then I don't know if you follow Rob Hamilton
Yeah,
or
sure.
Becca over at Anchor Watch, but I'm fans of them too. I mean, building an insurance product around Bitcoin. But, where do you see like oil and gas specifically? We're talking to a lot of upstream folks and kind of having a background in that. How do you see oil and gas connecting with Bitcoin on a larger basis? Like, I know we can take flared gas and start mining Bitcoin off of that. There's companies that do that, like Upstream Data, for example. But if you were talking to someone that's drilling or producing, where would you say, hey, look, this is a benefit of Bitcoin and why you should be taking advantage of some of those opportunities right now?
Yeah, so that's a really good question. And I think the way I think about it is, and so what we're doing right now is we're buying an older gas generating facility out in West Texas and at one of the larger cities in West Texas, and we're going to re-energize it, but it's connected to two of the largest laterals in West Texas for gas transport, right?
All
Well,
right.
the vision there is building an energy campus out with AI campuses that have their own gas powered generation, but then you're using that original plant as effectively balancing load across the entire facility that then interacts with the grid. Well, that
Mm-hmm.
balancing load is going to be batteries and Bitcoin ASICs.
Okay. All right.
Because it's the most efficient way to maximize your gas consumption where you're having to purchase these off the market. Now, certainly I understand that there are a lot of fields where there are congested or there's, gathering issues. We've had conversations with several pipeline companies and continue to engage with them on a lot of aspects how we can work together. But I mean, there have been
Yeah.
talks of installing flexible load at pumping stations to help reduce, monetize some of those flows that are as they're moving through the pipelines. I do think and this is, everyone's right. Everyone's got a right to an opinion, I guess, but kind of
Yeah. Yeah.
where I see the market going is you're going to see those like flare gas miners or flare
Mm-hmm.
gas mining setups, I think are going to continue to mature. And it just screams like a product that like Schlumberger or Halliburton, Big Red or Big Blue is going to get into
Right.
it at one point and be like,
Yeah.
okay, we ordered 100,000 containers. We're going to put it at every well we have to.
I'm surprised they haven't already,
I kind
honestly.
of am too, honestly, Peter. I think that's like a pretty like in your face solve there because ultimately you do need some of that scale. I think it's going to become increasingly difficult for front of the meter or like, in front of the distribution line mining to work unless you have a really unique setup with kind of how that is working. And so
Yeah.
for me, I think about it as like it's a tool in the business model as far as how to incorporate Bitcoin mining to improve your P&L or your revenue or your business plan, so
Yeah.
we look at it as an opportunity, like having a super highly flexible load is like super unique on the power grid, right? And so we can monetize that to the point where, I mean, our view is by the end of the decade, 50 to 70% of the revenues from the facility could come from power marketing versus just straight hashing and Bitcoin mining. Where I've
Okay.
gotten a little stuck on some of the flare gas guys is I don't exactly see what that second usage is. I guess it would be if your spot price rises above a certain amount, you curtail and you flow outward.
Mm-hmm.
But I mean, I think the team over at Upstream does a really good job. They have a good product and they're very straightforward and straight shooters. I think it's going to become continue to be integrated as like a grid appliance, right? Like the refineries, the LNG trains, the pipelines. It just doesn't make sense to have. I mean, I've seen Exxon blow a mountain up to change a pipeline by like a couple of degrees, right?
Yeah.
When you have that clear waste stream there that you can monetize, historically the energy industry has been very aggressive about it. So I'm pretty bullish on the energy industry getting deeper into it. I do think it's going to become harder for retail unless you're like hosting through one of these services at one of these facilities to really get as much exposure.
This is the conversation that has really energized me the most, where I've kind of found myself as I'm between, this interest in Bitcoin that I don't talk about very much just because, I don't know, it's kind of a polarizing topic for a lot of people, but then you got Bitcoin, energy, and then this, insurance and risk management side. And it's kind of fun to like talk with people that share similar interests and you can get into the weeds on it. So
yeah, well, I'm going to warn you, Peter, don't go down the working capital hole because that'll break your brain. There are literal like hundreds of billions of dollars just posted as collateral for like moving gas, and like the potential there for having kind of a neutral asset or an energy based asset like Bitcoin help settle those kinds of collateral flows is also interesting. So I mean, I think that's part of why it's an interesting topic, especially if you've been in the energy space, because it just starts touching like all the different pieces, and it's a helpful construct.
Don't tease me now. I got to go find someone to, dig into that one, and I'll just spend days on it now. Well, Joe, this has been such a great conversation. I know we lost Wade there. I think he had a call that came in, but thank you for coming on. Please give people a handoff where they can find you or connect.
Sure. I'm on LinkedIn at Joe Dillon, Joseph Dillon, and then you can find me on Twitter. It's at Tulane Joe, or I go by that Joe on there. And our website's at ataconenergy.com, and feel free to reach out, send me a DM, ping me. We're pretty active in the space and always love to talk. I mean, there's more addressable work to do than there are bodies to do it. So we're just doing the best we can.
Well, Joe, thanks for coming on.
Awesome. Thank you, Peter. Thanks for having me.
All right. Hey, before I let you go, and I know you got a busy day, but the word Atacon, what does Atacon stand for?
So Atacon I have a Osage Indian out of Oklahoma is my heritage, and Atacon is the Osage Indian word for sun, power, oil, and energy.
Oh, I love that. That's great. I
Good,
love
right?
that.
So
That's
technically
really
it's energy solutions, but we don't need to talk about that part.
Right. Yeah, no, it's still cool. The etymology is amazing. I love it.
So I saw that and I was like, oh, this is cool. It's like it's a nod to heritage. Everybody in the oil industry has got like Smith Drilling Inc. You want something that's has a little bit of a name to it.
Yeah.
And I love telling that story. So that's
and the domain's available, right? So that's the other part, right?
Well, some guy in Germany's got just Atacon.com. I got to try and track him down, but I got the Atacon Energy, and we'll just keep plucking away.
Yeah, I love it. Yeah, we got our localenergy.com domain. That was a journey, but that stuff's fun, right? It's enjoyable. So, well, man, thank you for coming on.